suppose that f of x equals 4x plus 3. And I want to calculate the derivative of that function. Well, the definition of derivative is the limit as h goes to 0 of f of x plus h minus f of x over h. F of x is easy. I have it written out right there. F of x plus h, well, I need to put an x plus h in here, right? That's going to give me four x plus h plus 3 minus 4x plus 3. What should we do there?
I don't know, because we can't put 0 in for h.
We can't put 0 in for h.
Well, it's going to be 4x plus 4h.
Okay.
The right
So,
minus 4.
let's try distributing.
Yeah,
That's a good idea.
distribute.
So 4x plus 4h plus 3. Distribute that negative minus 4x minus 3. Then what?
4x minus 4x, 3
4x minus 4x, 3 minus 3.
So if we have 4h
Now things are
over
looking
8,
good.
then we're looking at 3.
Limit as h goes to 0, 4h over h. By the way, if you're taking a limit using the definition of derivative, usually these problems, all the terms that don't have h's in the denominator will cancel.
Yeah, you said that.
And if they don't, you want to go back. Now, either that means that the limit is not defined, which is possible, or more commonly that you made a typo. Okay, so now what are we going to do with this limit?
It's just 4, so they just cancel.
Those h's cancel. Remember, we call that algebraic cancellation. And we have the limit as h goes to 0 of 4. Now, this is a constant function, but I still want to ask that question. As h goes to 0, what does 4 become? 4 stays 4. 4 doesn't really care what h becomes, right? So, that is 4. Okay, so timeout. What's derivative? 4. What does derivative mean? I'd like 2 synonyms.
The slope?
Okay, good.
Yeah, slope.
One is the slope. The other, rate.
Oh, okay.
Yeah, slope and rate. Those are the words that should come to mind. Now, in retrospect, what would you expect the slope of this line to be? 4.
Because you're intercept.
The
1
slope
equals 3.
sure looks like it's 4. The rate of change should be 1 over 4 up, right? That is. So that's the rate, that's the slope. This really agrees with the integral we already have. So, if you ever have a function that you know is flat, that you know its slope is 0, you ought to expect its derivative to be 0, right? So, don't ever lose that sort of connection. It's really important that you keep that connection, particularly if you're going to sort of talk people through intuition behind graphs. You want them to keep that idea of what a rate looks like.